Okay, welcome to 1.4 Angle Measure Notes. Here we're going to talk about how to name an angle and how to classify an angle, which are two different things. At any point you need to pause it to write some of this down, go ahead and then come on back. But here's an angle. It consists of two non-collinear rays that have the same endpoint. So what that means is this ray here has an endpoint here and is going off in one direction, and then there's another ray sharing that endpoint going in this direction. And if you combine them into one figure, you get this angle. Okay? The rays are called the sides of the angle, and then this endpoint that they share is called the vertex of the angle. We measure angles in degrees, and we use a protractor to do it. So you're all familiar with angles. How are we going to name specific angles in geometry? Well, there's three ways. So, for example, using this angle here, we can always name an angle using 3 points. You just have to make sure that the middle letter that you use to name it is the vertex. So I could call this angle PMO, or I could call it angle OMP. Same thing. You can always do that. Sometimes we just use the vertex to name the angle. So this angle sitting here by itself, we might just call it angle M just to abbreviate it. If you called this angle M, that would be fine. One thing you need to take into account though is that sometimes there's more than one angle that shares a vertex. So if you look over here, okay, this is angle ADC, this angle I'm tracing. There's two other smaller angles that make it up, ADB and BDC. So we can't call any of those angles in this picture just angle D because there's three angles that share that vertex, and if you just said angle D, we wouldn't know what angle you're talking about. But in this picture, if you say angle M, there's only one angle it could be, so we know what you're talking about. Okay? So you can name it with 3 letters, PMO. Sometimes you can name it with just one letter, just the vertex, M. And then sometimes we use a number. So if you see here, in this case, angle PMO is also being labeled as angle 4. So you could also call this angle 4. Just remember, if there was a degree symbol here next to the 4, that's saying that angle M measures 4 degrees. That's not the name of the angle. So just look for a degree symbol. No degree symbol here, so you can call it angle 4. Okay? That's how you name an angle. Either 3 letters, just a vertex, if there's no other angles using that vertex, or sometimes a number. Now we can classify an angle, so categorize it based on its measure of degrees. And I think you've probably seen these terms before. An acute angle is one that's between 0 and 90. Here's some examples. A right angle is exactly 90 degrees. An obtuse angle is bigger than 90 but less than 180. And then a straight angle, straight line, is exactly 180. So again, go ahead if you need to pause it and fill that out. Okay. Now, again, looking at this picture, how many angles are in this picture? If you said 2, this one and this one, you're also forgetting angle STH, the entire angle, the biggest angle, right? So there's actually three angles in that picture, and all of them have a vertex of T. Now, which of the 3 angles has the smallest measure? That would be CTH, right? So we go angle CTH. This M here means what is the measure of angle HTS. So HTS is this one. Well, if this one is 30 and this one is 65, what's the whole thing? You're going to add them up. You get 95 degrees. HTS is 95 degrees. Now, CTS is 65 degrees. So when they ask you to classify it, you're going to say it's acute. And the angle addition equation just means kind of like what we do with science. We're going to use next semester, part equals whole. So in this case, it would be this plus this equals the whole thing. So you're going to go angle HTC plus angle CTS equals the whole thing, which is angle HT. Now, you probably could have just figured that out by looking at it, right? Oh, this is 30, this is 65. So if I want to know the measure of the whole thing, I'm going to add up these two numbers, right? Well, it's important to know this is a way we can think about it because sometimes we don't get just numbers for angle measures. Sometimes they give us expressions and we have to use algebra. So we'll take a look at that coming up. So in example 2, just go ahead and, label them. O, M, N. Start at the O, go to the M, go to the N. This angle right here is 50 degrees. Angle LMO is this. So what's they want you to find um, in this one, I want to know the measure of DEF, which is the entire thing. Sorry, I'm having issues. So, let's label what we have, write out the equation in algebra, and then we'll be able to solve. So DEG is this one. It's going to be 9x plus 5. I'm just going to label that right in there. GEF is 37. And then FED is the whole thing. Well, just like when segment particles whole, do the same thing with angles. This plus this is going to equal the entire big angle, which is FED. So we're going to have equals minus. I have an extra number. So I'm going to subtract it. Well, 54 equals 6. So x equals 9. Now, they didn't ask me what is x. They said find DEF. So you can take this and substitute it back into there to get an angle measure, which is 9 times 9 plus 5. 81 plus 5, which is 86 degrees. That's 86. That's 37. Add them up to get DEF. So DEF would be 86 plus 37 is 1. Now, we have another term here. A lot of terms. this is saying something a ray that divides an angle into two congruent angles. No, it's saying that that's called an angle bisector. It's similar to, for example, like a midpoint on a segment. We already know if an angle is cut into two different parts, that the parts added up equal the whole. But in this case, the two parts are going to be congruent. So let's try that. Let's draw an angle. So it tells us to draw an angle. Angle A. Remember, the middle letter is going to be something like now, I'm going to draw a ray called JK, which is bisecting C. So start at J. Okay. So there's K. There we go. So when we say that JK bisects HKL, then we're going to want to paste it. I'm very different. So just draw that. And it should look like this. One, two. We use these arcs here to label congruent angles. So, if HJL, if the entire angle is 42 degrees, then how many degrees are these smaller angles, HJK and KJL? Well, you would just do 42 divided by 2. That's where we got the 21 from. Now, looking at the next one, we're going to have an angle bisector. I think if we draw a figure, it might help a little bit. That. That's a little bit. All right. Just not draw angles. I need to go. All right. Label these congruent. There we go. And then let's label everything. So CMH is the big one. CMH. And then MP is the bisector. So P is somewhere around here. Okay. Now, CMP is 8x minus 13. Usually we'd write it right here, but I need a little more space for my phone. And then PMH is this one, 6x plus 11. Now, we can do part plus part equals whole, right? So if they had told us an expression for CMH, we could do this plus this equals the whole thing. They didn't tell us that. But they did tell us that MP is an angle bisector, which means the two smaller angles, this one and this one, have to be congruent. So we're just going to set these equal to solve for x. And that's going to look like this. So we're going to set them equal, solve for x. Now they want to know CMH, which is the whole thing. So we're going to substitute the 12 back in for both of these expressions, and they should be equal. It should be the same number, so we get an 83 and an 83. So what's CMH? 83 plus 83 is 166. Okay? So we know how to name angles. 3 letters always works, sometimes 1 letter, sometimes a number. We know how to classify them: acute, obtuse, straight, right. We know how to use angle bisectors to find certain angle measures, right? The last thing we need to do is how do I measure an angle using a protractor? Well, this is what a protractor looks like. Okay, so what you're going to want to do is line up the protractor. So here's an angle. See the blue angle? You want one of the rays of the angle to go along this starting line here on the protractor. And then you're just going to see where does the other ray hit the protractor. Now if you'll notice there's two sets of numbers here. So you actually just have to know which set of numbers am I going to use. So look at the blue angle. You see how it's an acute angle? It's less than 90 degrees. So when I'm looking at the numbers and I say, which of these do I use? Do I use the 80 or the 100? You would use the one that's less than 90. So that's how we know this blue angle is 80. Okay? If it looked like this, now look at the blue angle. I still have one ray lined up on this line. Where do I hit? I'm hitting right here. It's either 80 or 100. Well, look at it. Here's 90. It's bigger than 90, so I'm going to use the measurement that's bigger than 90. It's 100. So you'll practice that in class. You know, feel free to look this over, reference these notes whenever you have to do the homework, and you should be good to go with angles and their measure.